In this video, we're going to look at some more difficult examples of trig integrals. Here we have integral tan cubed x divided by root secant x dx. Let's rewrite tan cubed x as sine cubed over cos cubed, because tan x is sine x over cos x. So we have sine cubed x divided by cos cubed x times 1 over root secant x dx. Now, whenever you see an odd power, the best thing to do is to reduce the odd power by 1. So we're going to split off a factor of sine x. Let's write this as sine squared x over cos cubed x times 1 divided by root secant x times sine x dx. Now let's apply a trig identity to write sine squared x as 1 minus cos squared x. So we have integral 1 minus cos squared x divided by cos cubed x times 1 over root sec x times sine x dx. So what we have is 1 minus cos squared x divided by cos cubed x times 1 over root sec x times sine x dx. And let's rewrite 1 over root sec x as root of cos x, because secant x is just 1 over cos x. So we have integral 1 minus cos squared x divided by cos cubed x times root cos x times sine x dx. Now, the next step here would be to let u be equal to cosine x, because its derivative will take care of sine x dx. So let's do that. U is equal to cosine x. Du is minus sine x dx. All right, let's label everything. So here we have 1 minus u squared. In the bottom, we have u cubed. And here we have root of u, and sine x dx is this part will be minus du. So we have I'll put the minus outside, it will be easier to do. We get 1 minus u squared divided by u cubed. Root of cos x, that's root of u, times sine x dx, that's going to be minus du, and we have the minus in front of the integral. So let's simplify this. Let's multiply root u by 1 minus u squared, and we're going to get minus integral u to the 1/2 minus u to the power of 2.5 divided by u cubed du. Now let's split off the fractions, and we get minus integral u to the 1/2 divided by u cubed. That's 1/2 minus 3. They got the same base, so we get u to the minus 2.5 minus u to the 2.5 divided by u cubed. That gives us u to the minus 0.5 integrated with respect to u. So what we have is integral u to the negative 2.5 minus u to the negative 0.5 integrated with respect to u. We're going to reverse the power rule. So we have minus, what is the antiderivative of u to the minus 2.5? We add 1 to the exponent and divide by the same. So we get u to the negative 1.5 divided by negative 1.5 minus u to the negative 0.5 plus 1, that's u to the 0.5 divided by 0.5 plus c. Now let's do some algebra. 1 over 1.5 is 1 over 3/2. That's the same as 2/3. And the minuses cancel out. We get 2/3 times 1 over u to the 3/2 plus 2, because 1 over 0.5 is 2. And negative times negative gives us a plus. So we get plus 2 u to the 1/2 plus c. Now let's put u back in. U is equal to cosine x. So what we get is 2/3 times 1 over cos x to the power of 3/2 plus 2 times cos x to the power of 1/2 plus c. So the answer to the integral, integral tan cubed x divided by root sec x dx is equal to 2/3 times 1 over cos x to the power of 3/2 plus 2 times cos x to the power of 1/2 plus c. All right, let's look at another question. Here we have integral from 0 to power over 4, root of 1 minus cos 4 theta d theta. We have a definite integral. We have limits. The upper limit power over 4, lower limit is 0. The first thing to do is to apply some trig identities so we can make this easier to solve. So what we have is integral 0 to power over 4. Now we have to ask ourselves, how can we rewrite 1 minus cosine 4 theta? So you can see from trig identity sine squared theta, the half angle identity, sine squared theta is equal to 1/2 times 1 minus cosine 2 theta. That means sine squared 2 theta would be 1/2 times 1 minus cosine 4 theta. Notice the 2-to-1 relationship. When this is theta, we've got 2 theta. When the angle is 2 theta, we've got 4 theta. So let's solve for 1 minus cosine 4 theta and put that inside the radical. So we have root of 2 sine squared 2 theta d theta. Let's factor out the root 2 and put it in front of the integral. We have root 2 integral 0 to power over 4 root of sine squared 2 theta d theta. Well, that's going to give us root 2 0 to power over 4. Now the square root cancels the square and we get absolute value of sine 2 theta d theta. Now bear in mind that sine 2 theta is positive when theta is between power over 4 and 0. That means that we don't need the absolute value. So we can rewrite the integrand as root 2 integral from 0 to power over 4 sine 2 theta d theta. Alright, so what we have is root 2 times integral from 0 to power over 4 sine 2 theta d theta, and this is just an integral that we can solve by using method of U substitution by letting u be equal to 2 theta, du is 2 times d theta. But because it's easy, we can just mentally solve that. The integral of sine of 2 theta will be minus cos of 2 theta divided by 2. So what we have is root 2 times antiderivative of sine 2 theta, that's minus cos 2 theta, divided by 2. So we're basically reversing the chain rule, and then evaluate it from 0 to power over 4. Now let's rewrite this as minus root 2 divided by 2 times cosine 2 theta. So put the upper limit and apply the fundamental theorem of calculus. We get cos of pi over 2 minus cos of 0. So what we get is minus root 2 over 2. What is cosine of pi over 2? That's cos of 90 degrees. Cos of pi over 2 is 0. What is cos of 0? Cos of 0 is 1. So when we simplify this, we get minus times minus, and we'll get root 2 divided by 2. So we have solved the integral from 0 to pi over 4, root of 1 minus cos 4 theta d theta, to be root 2 over 2. All right, thanks.